let's look at the first one. The first one we're going to look at is this. We have the absolute value of 2x minus 5 plus 2 is equal to 8. So in solving an absolute value equation, just like we did with the square root, you got to get the absolute value by itself. So we have to isolate this by itself. So I'm going to rewrite this as absolute value 2x minus 5. So I'm going to subtract 2 from both sides, and so that's going to equal 6. All right, so you got to get the absolute value by itself. So I'm going to subtract 2 from both sides, and so I get the absolute value of 2x minus 5 equals 6. Once you get to that point, when you look at those lessons, you're going to see that once you get to that point, you're going to split this into two equations. You're going to split into two equations without absolute value bars. Without absolute value bars. Can't spell absolute value bars. So you split it into two equations. So you must have two equations. So you're going to say 2x minus 5 equals 6. And then 2x minus 5 equals a negative 6. So the way you're going to write it, you're going to see this 6 right here. So you're going to say 6 and negative 6. So in one equation, you're going to have a positive 6. On the other equation, you have a negative 6. Now, the reason for that is in your lessons. We don't have time in this review to talk about the reason, but the reason is in those lessons. So notice that this stayed the same without absolute value bars. And then on this side, you wrote equal positive 6, and then its opposite, negative 6. So it's always this number 6 and its opposite. Okay? Now notice I went from an absolute value equation to two linear. And so all you do is solve the linear and you're done. That's all you do. So I'm going to add 5 to both sides. And so I get 2x equal 11. And then x is 11 halves. You don't have to check these. Those you do not have to check. Okay? You do not have to check. And do the same thing here. Add 5 to both sides. And so I get 2x equal negative 6 plus 5 is a negative 1. And so x is negative 1 half. And that's it. That's all you do. So let's do a couple more. Number 2. Number 2, we have the absolute value of 2 minus 5x is equal to 7. So notice the absolute value is already by itself. So once it's already by itself, like we did here, you're going to split it. You always split. So that's what I'm going to be looking for. So when you split it, you're going to rewrite it without absolute value bars. So you're going to say 2 minus 5x equals 7. So you see what you're doing? You're just rewriting this over without the absolute value bars. You're rewriting this over without the absolute value bars. But on this side, though, you're going to put the opposite. So you're going to say 2 minus 5x equals, and then the opposite of 7 is a negative 7. And so now you just solve each of those equations. So I'm going to subtract 2 from both sides. So 2 minus 2 is at 0. So I get negative 5x equal 5. Divide both sides by negative 5. I get x to be negative 1. Over here, subtract 2 from both sides. This is 0 right here. 2 minus 2 is 0. So I get negative 5x is equal to negative 9. Divide both sides by negative 5. Negative 5 divided by negative 5 is 1. 1 times x is x equal a negative divided by negative is a positive. So I get 9x. So those are your solutions. The only time you have to check is when you raise both sides to the even power. And I did not do that here. All right, now let's look at number 3. So number 3, let's suppose you had this in number 3. All right, now don't let number 3 throw you off. The absolute value of 3x minus 1 is equal to x plus 2. Okay, now you see there are variables on both sides. You have variables on both sides. Here, you did not have variables on both sides. So you did not have to check these. I didn't check those because there was only variable here. There was no variable on the other side. Here, though, I have variables on both sides. So if there are variables on both sides, you need to check. Okay, so you have to check. All right, so you can do the same thing. So you're going to rewrite this. See, the absolute value is by itself. So this is the only one that has absolute value. So you're going to rewrite this without absolute value bars. So you're going to say 3x minus 1 equal x plus 2. So you see this, you rewrite, just like you did this one. So I just rewrote it. Now on this side, though, you're going to take the opposite of what's over here. Okay, now listen carefully to what I'm saying. So 3x minus 1 equal the opposite of x plus 2. So the opposite of x plus 2 is where you take the opposite of each term. So the opposite of x is a negative x. The opposite of 2 is a negative 2. And so that goes here, negative x minus 2. And that's all you do on this side. So you just take the opposite of each term. Opposite of x is negative x. Opposite of positive 2 is negative 2. And then you solve each of those linear equations. So you're going to subtract x from both sides. So 3x minus x is 2x minus 1 equal. And then over here you get 2. Add 1 to both sides. You get 2x equal 3. So x is 3 halves. Okay, over here, do the same thing. Now, got to be careful. See, this is negative x. See how I subtracted x here? Because x minus x is 0. Here you're going to add x now to both sides. So add x to both sides. 3x plus x is 4x minus 1 equal a negative 2. X and negative x is 0, so you're left with negative 2. Add 1 to both sides. I get 4x equal negative 1. Negative 2 plus 1 is negative 1. Divide both sides by 4. I get x to be negative 1/4. All right, so since there are variables on both sides, you have to check this because it could turn out, see, the absolute value of a number is always positive or 0. It could turn out that this is negative, so you have to check both sides. Okay, so you may need your calculator for this one. So let's check. All right, I'm going to go back and rewrite the original. So you have 3x minus 1 equal x plus 2. So where we see the variable x, I'm going to substitute 3 halves. All right, so there's going to be a little bit of work here. So just use your calculator if you need to. So that's 3 times 3 halves minus 1. Okay, so wherever we saw the variable x, substitute 3 halves. I'm checking x equal 3 halves. Equal, and then 3 halves plus 2. Well, 3 times 3 halves, 3 times 3 is 9. So that is 9 halves minus 1. And remember, 9 halves is 4.5, right? So 9 divided by 2 is 4.5. And 4.5 minus 1 is 3.5. And the absolute value of 3.5 is 3.5. Over here, this is 1.5 plus 2, which equals 3.5. And so those are the same. And so 3 halves will work. Now you do the same thing with negative 1/4. All right, so if I check x equal negative 1/4, go back to the original, or write the original. Here was the original. Okay, and wherever we see the variable x, I'm substitute negative 1/4, which is, since this terminates, I'm going to go ahead and use a decimal. That's negative 0.25. So I get 3 times, let me just go ahead and use negative 1/4. So 3 times negative 1/4, x is negative 1/4 minus 1, absolute value of that. And I want to see if that's going to equal negative 1/4 plus 2. Well, 3 times negative 1/4 is a negative 3/4 minus 1. And a negative 3/4 minus 1 is a negative 1 3/4, which is a positive 1 3/4. So negative 3/4 and negative 1 is a negative 1 3/4, and the absolute value of negative 1 3/4 is a positive 1 3/4. I want you to notice this right here. Negative 1/4 plus 2 is also equal to 1 3/4. So those are equal. So x equal negative 1/4 is also a solution. So these two actually work. So those two are your solutions. Now the reason why, just to remind you, the reason why you have to check this is because one of these numbers could have made this side negative, and the absolute value of a number is always positive or 0, and a positive number is never negative, and a 0 is never negative. So that's why you have to check. Let's see, let me see what someone's asking. Hold on. I saw there was someone in chat asking something, and I just can't see what they're asking. Okay, so
somebody was asking if had some audio trouble.
Oh yeah. If you're the only one, then it's probably your computer. You may need to raise your volume on your own computer. Okay. Thanks for letting me know what they were saying because I can't see the chat on my side. All I saw was it blinking. Okay, let's do.
I don't know if anyone else is having the problem, but I think you're just moving around the mic or the mic is placed weird because there are moments where you're harder to hear, but generally we can hear.
Yeah, well, I'm actually at the computer. It's like 1 foot away, so um, that's the best I can do with this. Um, okay, so let's look at number 4. So in number 4, let's look at this. We have the absolute value of 2x plus 1 is equal to 3x minus 4. So again, notice you have absolute value and the variables on both sides. So you need to check because whatever your possible solutions are, it could make this negative. And this side's always going to be positive or 0 because the absolute value of a number is always positive or 0, never negative. So we're going to split it apart. So you get 2x plus 1 equal 3x minus 4. And you get 2x plus 1 equals, now remember the opposite. So the opposite of 3x is a negative 3x. And the opposite of a negative 4 is a positive 4. Okay, so don't forget, this is always the opposite. You always put the opposite here, the opposite. And then notice I went from an absolute value equation to 2 linear. So let's go ahead and bring the variables to this side. So I have to subtract 2x from both sides. So I get 1 equals 3x minus 2x is x minus 4. And then add 4 to both sides. I get 5 equal x. All right, now I've got to check this at some point. All right, let's do this one now. So over here, I'm gonna go ahead and bring the variables to this side. So I'm gonna add 3x to both sides. So 2x plus 3x is 5x plus 1 equal, this is 0, so I get 4. Subtract 1 from both sides, I get 5x equal 3, and so x is 3/5. All right, now remember you got to check because we got to make sure that this side equals this side. So let's do x equal 5 first. So let's check x equal 5. So I get the absolute value 2x plus 1 equal 3x minus 4. So in place of x, I'm going to substitute 5. So I get 2 times 5 plus 1, absolute value of that. On this side, I get 3 times 5 minus 4. 2 times 5 is 10. Absolute value of 10 plus 1. 10 plus 1 is 11. And the absolute value of 11 is 11. Over here, this is 15 minus 4, which is 11. So those equal. So this works. Now we go to this one. So you got to check the next one. So check x equal 3/5. All right, so here was the original. So I have the absolute value of 2x, that's absolute value. The absolute value of 2x plus 1 equal 3x minus 4. So wherever I see the variable x, I'm going to substitute 3/5. So I get the absolute value of 2 times 3/5 plus 1 equal 3 times 3/5 minus 4. 2 times 3/5, 2 times 3 is 6, so that's 6/5 plus 1. And on this side, I get 3 times 3/5 is 9/5 minus 4. 9/5 minus 4. Well, 6/5 plus 1 is going to be 6/5 plus 5/5, that's 11/5, which is 11/5. Absolute value of 11/5 is 11/5. 9/5 minus 4 is 9/5 minus 20/5, because 20 divided by 5 is 4, which is a negative 11/5. So those are not equal. All right, so you see what happened? So you see those two sides are not equal. All right, so that means that 3/5 does not work. See, this is negative. This side, the absolute value of a number is always going to be positive or 0. It's never going to be negative. So you have a positive 11/5 equal to a negative 11/5, and that is not true. So that's why you have to check. Whenever you have variables on both sides, absolute value, you need to check because this could be negative. See, if this is negative, and it is right here, then that's not a solution. So your only solution is this. So the solution is x equal 5. That's the only solution. So there were a couple of hard things that we talked about in today's review. So just make sure when you get to this topic on absolute value equations, you go through the lessons. You actually go through it. You look at the examples given. You look at the PDFs of the lessons, and you just use those to help you to understand how to work these problems. All right, so I'm going to go ahead and end this part